Hello, welcome to my space station. Today, let's explore about astrodynamics. Now, basically, this is a field where we deal with the movements of spacecraft and related things in space, right? And this field just helps us a lot in, say, launching a probe into space, setting a satellite around orbit, and it's very important when it comes to space exploration. So let's try to explore in this video two of the most basic maneuvers used in astrodynamics that relate to the changing of orbits. That is the Hohmann transfer and the Bi-Elliptic transfer. Let's get into this. So if any of you have played any games, right, there are many games online which relate to the simulation of spacecraft. I remember also playing this as a child. I used to just mess around with these spacecraft and I would try to just fire the thrusters randomly, not aware of the physics behind it. But as I grew up, I also found out that there was still a lot of thought behind this, right? All of these maneuvers which I did randomly had a lot of science behind it, and then they were discovered. And then that comes to one of those biggest questions when you get into space flight. How do you go from one orbit A to another orbit B? Right? Because it's not as simple in real life that if I have two circles, I want to go to the other circle, I can just walk over to it. It's not as simple. And it's also further complicated by the fact that there's no friction in space, so you kind of have to slow down your spacecraft by yourself. Friction doesn't exist, so it's very more complicated. So there were two main methods developed. First, the Hohmann transfer and the Bi-Elliptic transfer. The Hohmann transfer, named after a German astrophysicist, right, who worked for the Nazis, and then over the course of the development of the V2 rocket, he also had to develop some sort of ways for the rocket to change its orbits, and so that was developed at a smaller scale. But after he worked for the Americans, when he worked on bigger projects, right, ones which had spacecraft going into full orbits around the Earth, not only the small orbit that the V2 took, he developed the Hohmann transfer, which is a way to go from one orbit to another orbit. Now, the Hohmann transfer and the Bi-Elliptic transfer they are pretty same in the way that they change the orbits. They both go into elliptical orbits first and then transfer onto a circular orbit again. But the main difference between them is that the Hohmann transfer, though it uses less thrust meaning like it fires the rockets only twice, it requires more energy and it changes the velocity by a lot, and hence it needs a lot of thrust and so a lot of fuel. But the Bi-Elliptic transfer is a more fuel efficient, right, because it changes the velocity by less and it uses less energy, but it takes three bursts of the rocket to do so. So let's delve into how these two maneuvers work. Let's say you're in orbit A around the Earth and you want to go a bit further into orbit B, right? So the Hohmann transfer would necessitate that you first make an elliptical orbit whose apogee touches the circumference of the orbit B. So basically, you're in one circle, you're in another circle. All you need is an ellipse. It's an elliptical circle which goes here, and that's achieved by firing the boosters in the opposite direction which you're going, which extends your orbit to there. Now, if you do nothing further, you will just be going in this elliptical orbit because, like I said, there's no friction in space, and you just keep accelerating, right? Unless you slow yourself down. So the Hohmann transfer, what it basically does is that as soon as you're at the apogee, you turn around again in direction of the circular orbit, right? And as you would have known in physics, in basic physics, when you talk about centripetal force, that the object's motion is as a tangent to the circle. Basically, there's a circle, and the point where a line touches the circle circumference is called a tangent. So basically, we learned that the motion is with the tangent of that circle. So what you're doing is that as soon as your spacecraft is facing towards that tangent, you fire motors again, right? You fire your thrusters again for the second time, and this extends the orbit from the elliptical one into a circular one, right? And now you're in circular object around B. This takes up way more thrust, way more energy, but it only fires the boosters twice, right? This is a more less energy efficient transfer, the Hohmann transfer, and yes, it is used because it only takes twice bursts and it does not go beyond orbit B. Let's say there is a danger above orbit B and you don't want to go beyond that, you just want to go into orbit B, you don't want to go beyond orbit B. That's when you will use the Hohmann transfer. But the Bi-Elliptical transfer does go beyond orbit B. It follows a more convoluted path. Basically, what you do is that, let's say you're in orbit A and you need to go to orbit B. The same approach, you first get into elliptical orbit, but not till the radius of orbit B, but beyond that. You first fire the rocket boosters, just a small amount, right, for the first time, and you get launched in orbit whose apogee is way beyond the orbit B. So now you go far. Now first you will just glide along that, and then as soon as you reach the apogee, you will fire your boosters again. This time in this time facing towards that, right? Facing towards where you want to go. In the Hohmann transfer, will be faced away from it to extend our orbit. Right now we're going to face towards it to make our orbit smaller. Now what it does is that the other side of our elliptical object shortens, and this time it reaches towards the circumference of orbit B where we want to go. So now we just cruise around that point. That was our second rocket fire, and then again, now as soon as we are at the point of orbit B, same thing. As soon as we are tangent to that, we will fire rocket motors again for the third time, and that will shorten our object on both sides and make it circular. Now we're on orbit B. This was the bi-elliptical transfer, and though it fires the rocket boosters 3 times as compared to the Hohmann's 2 times, it does use less energy, less fuel, and so the change in velocity is less as compared to the Hohmann transfer. This is a more fuel efficient way, but it does go beyond orbit B, and when it comes to, let's say there's an asteroid belt or some sort of danger there, it's pretty inefficient. You don't really want to do it. It's too much of a risk, right? So these two maneuvers are the most basic ways to change an orbit. And then when you want to stay into that orbit, there has to be, because eventually your speed will decrease, that you will, if you don't control yourself, fall back to the atmosphere. So there are more boosters, more thrust required to stabilize your orbit, right? And then that's when we get to the Lagrange points. I've covered them before in one of my videos. The Lagrange points at where the gravities of two celestial bodies cancel out, and so there's a stable orbit there. When you get to the Lagrange point, there's no further stabilization required, because anyways you're stable. Physics lets you be stable. So I hope you enjoyed the video about this, and I will be sure to post more videos which relate to this field of astrodynamics, so that we can understand more about how our satellites, how our spacecraft even get to the other planet in the first place, because it's definitely not as simple as firing a rocket and just praying it goes there. There's a lot of physics and a lot of math involved behind it, which I would love to cover on this channel. So I hope you enjoyed my video and learned a lot about the Hohmann transfer and the bi-elliptical transfer, and I'll see you next time. Thank you.